Still on electricity and chemistry, we're going to talk about the industrial applications of electrolysis. Now, electrolysis is applied in the industries in several categories. Now, they've been grouped, and then we can have electroplating, we can have purification or refinery of metals. We can also talk about extraction of metals, anodizing, and then manufacture of chemicals. So we'll be talking about electroplating, purification or refinery of metals, extraction of metals, and then manufacture of chemicals. Let's start with the electroplating. Electroplating is when we deposit a thin layer of metal on the surface of a cathode. We're going to deposit a thin layer of metal on the surface of a cathode. Okay. Now, we've heard of a gold-plated watch, a copper-plated nail. All these, we arrive at all these through the process of electrolysis. Now, there are certain adjustments we make to our normal electrolysis setup. The first one is that the anode is made of the metal we want to use in electroplating. The anode is made of the metal we want to use in electroplating. So, for example, if you want to use copper to cover a nail, the anode should be copper. Ions of the same metal as anode is used in the solution. So, the solution should be a salt of copper. So, for example, the electrolyte will be copper sulfate. And then the cathode, the place where the cations will go, will be the metal on whose surface we want to do the electroplating. Let's look at an example where we use the nail. Now, the first thing we're going to take note is that the first rule or the first adjustment was that we were going to use the metal we want to use in electroplating as our anode. So in this case, we've used copper as our anode. Now, this solution is a copper sulfate solution. A copper sulfate solution. So once they get into solution, the copper will dissociate. We get copper 2 plus ions in the solution. And then we get SO4 2 minus ions in there. It is a copper sulfate solution, but once we get the solution, they dissociate. And then the third rule was that the cathode should be the metal on whose surface we want to do the electroplating. So once we complete our circuit, the copper ions will start migrating to the cathode where the nail is. Now, as they are migrating, this copper also starts to dissolve. It starts to dissolve to replace the ions in here. The copper will start to dissolve to replace the copper ions that are formed or that are being formed on the surface of the nail. So with time, you see that this copper is going to lose its mass. And then eventually, it will be formed on the nail. Now let's see some examples or the importance. Let's talk about the importance and then we move on to examples. It makes things beautiful. Example is a gold-plated watch. It makes it look very, very beautiful. Gold-plated phones, gold-plated car like this one here. Okay, there's a thin layer of gold deposited on the surface of the metal. It is making it look very beautiful. You can see this phone here. It also prevents corrosion. Let's say you have an iron substance like a nail, and then you don't want the nail to rust or to corrode. You can use copper. You can cover the surface of the nail with copper so that when it comes into contact with air and water, there will be no corrosion. So in this case, this key here has been copper plated. That means the key was the cathode, and then there was a copper anode, and this is the copper sulfate solution. So as the circuit was complete, the copper started to break down, and then the ions migrated to the key, where they got electrons and then became pure copper.